Hello everyone, my name is Vadim Orlov. I'm a CTO and co-founder of DataForge. DataForge was founded by the team of data engineers, and our motto is to simplify the complex and automate the tedious in the data engineering world. Frequent question we get from customers is this: Databricks is modern and very capable data platform. Why do I want to use DataForge? What advantages does it bring on top of all the features that Databricks already has? To answer that question, in this video, I'm going to review one of the common data engineering patterns, specifically change data capture, and to see how it's implemented in using Databricks Delta Life table library and compare and contrast it with DataForge cloud product. So let's get started. This is a blog where data engineering team from Databricks is covering the process. So the pattern, like I said, is change data capture. And in the first two paragraphs, the Databricks data engineering team did a really good job describing the pattern. So if you're not familiar with CDC or slowly changing dimension concept, definitely recommend reading these first two sections in detail, as it will help you to understand the pattern we are reviewing. So for this comparison, we're going to focus on configuring the pipeline for pulling and updating table snapshots from the source database table. The blog describes snapshots configuration process and details two strategies for the snapshots. So here's in this section you can see what are the snapshots. These are the strategies, push and pull. So we're going to focus on pull, so which basically involves receiving data from your database or pulling it from the database by configuring the query, and then we'll use snapshot accumulation approach or approach 2 because this is more realistic and this is typically what you would use in real production pipelines. So this good picture kind of details the approach. So this is snapshot accumulation 2 at the bottom. So the main idea is you keep collecting the snapshots, which are represented by files, by Parquet files in this case. So each Parquet file represents snapshot of your source table point in time. So in this picture, it's basically happening every hour. And then as you can see, after the third hour, you will have initial snapshot plus 3 hourly snapshots. One important note here is this whole process, how you connect, how you ingest the data, connect to a source database, configure the snapshots, design the storage and ingestion process. This is all outside of the scope of this particular blog. And the blog kind of assumes that you already pre-configured those snapshots and have them stored in your Databricks environment. This is important because in DataForge Cloud, we automate the whole process, and I'll show you and demonstrate later how it's done. So with that in mind, once the snapshots are configured and created, let's kind of look how would you approach creating the Delta Life table pipeline. So okay, so once these snapshots are configured and created, they can be referenced as a source table in the Delta Life table pipeline that we are about to configure. Let's see how this is done. So this paragraph describes the applied changes from snapshot functionality in the Delta Life table library. So here are some important things you need to keep in mind. So you can only use Python. These are the versions you need to have for your Databricks environment where it's supported. Then snapshots need to be passed in ascending order, so they are applied correctly. And then finally, you need to use sortable data type for the numbers, and you can use either SCD Type 1 or 2 methods, but not both. First, you start with defining your source table. So this is essentially telling the Delta Life table library where to read the snapshots from. So that's fairly straightforward. So this is a source table that they use in the example, orders table with order ID as a key, and then a few columns where they're going to simulate the changes. So you need to define the primary key, obviously, for this to work, which is order ID in this example. And then this is how you define the source table. So and then I'll skip the next section because, like I said, we're going to focus on using the snapshot accumulation approach 2, which is a little bit longer. To configure the process for snapshot accumulation approach 2, you need to start with defining the target table. So that's pretty straightforward. You just create table here, give it a name, some comments, say it's gold, and then comes a little bit tricky part. So now you need to tell the apply changes from snapshot process where to read the snapshots and how they should come in what order they should be coming. So for that, because as you recall, our snapshots were saved here as a bunch of different files, Parquet files, right? So now you basically need to tell this library in what order and how to read and apply those files. Okay. So let's jump into the code. So this is a code which details all this process. It's basically reading the files, extracting our timestamps from those files, calculating dates. So a lot of kind of boilerplate code to apply the snapshots at the right order. But the outcome, and this is a function which does all the work basically here. As you can see, it's just a Python function. And once it's done, it returns the specific path where the snapshots should be read from. And this is where you configure that function. So this is a function that you developed. This is the actual configuration for the DLT apply changes from snapshot method. So it specifies the target for the table. So this is your gold table. This is the mechanism for returning and applying those snapshots. These are your keys for the table. So in this case, it's order ID, as you recall. You specify that you want to store this as a SCD Type 2. And this option allows you to specify columns that you want to track history, so selectively. Sometimes you want to exclude or include specific columns. Once it's done, that's basically it. Now you have your own table. The pipeline runs. Once pipeline runs, your table is ready to use. And as new snapshot will arrive, it will automatically update the table. And finally, in the last section, the blog covers how you would approach developing Databricks Asset Bundles or DABs to help you manage this pipelines as a code. And it's a collection of Databricks YAML files, and they have a nice GitHub repo which you can look and where it kind of outlines the structure. So overall, this is a great, and DLT library definitely simplifies and automates many portions of the CDC data pipeline. It's definitely a huge time saver for data engineers. So anyone who's tried to do this or done this manually would agree with me, I'm sure. That being said, it will still probably take a few hours to fully configure, especially if you're doing it from kind of point of ingestion, right? Potentially you need extra tools, extra ingestion tools to connect to the Databricks to bring your data from external environments. So with that, let's jump to the DataForge, and I'll show you how we automated the entire process from ingestion of the source data and storing them in bronze and silver layers of a Delta Lake to performing CDC and generating the gold data set with both slowly changing dimension types 1 and 2 applied. So let me jump into SSMS first. So this is, I kind of replicated that similar or table that Databricks engineers used in their blog. So order ID, price, a few columns, added modified date, which we'll use later to kind of help us track the changes. So so let me jump into the DataForge now. So okay, so this is a connection for that SQL server that I was just showing you, and I already pre-configured this. So in DataForge, once you configure the connection, it automatically scrapes all the metadata for you. So I'm gonna help you understand the data structure. So in this case, we already have this table in the connection metadata. The table is called orders. You can see we also identify the primary keys automatically from that connection metadata. So all I need to do is just click this and say create source. So I'm gonna just call it. This gives me opportunity to specify the pattern for the source name. I'll create source and initiate data pool immediately. So what happens now is system created the new source for me. It's called orders. And while data is being pulled, I'll kind of quickly walk you through the configurations here. It's a table source. This is my connection. This is a query, so I'm just doing select star from the orders, very simple. Specify data refresh key. So key is what one of the patterns that we implemented in DataForge here, which kind of covers this change data capture with key data / slowly changing dimension. So we have many others here, but this is just one of them. This is a key column that we pulled from the metadata. You can change it. You can specify multiple ones. So kind of similar to DLT array of attributes. Scheduled, so you can define the schedule here and pull it. Okay, and that's it. So there are many other parameters here which I'll kind of leave out for now, but there are many other things you can override and can configure here. All right, so now the data is pulling from that orders table from the SQL server, and you can see here on the input step. So input represents DataForge batch, right? So basically every time you pull the data, the batch of data from the source, we in DataForge we create the input ID with you capture the timestamp, we capture the size of the data, record counts, and other metadata. So this is our built-in observability feature of the product. So you can also see the specific steps that each batch goes through, and those are kind of aligned to the medallion architecture stages in your Delta Lake, from raw data all the way to the gold, right? So what we've done here is, you can see we pulled this number of records, and if we look, if I click here, you can see that out of 31,948 records, all of them are marked as new. So record status, it's one extra kind of usability feature which we built in addition to like plain vanilla CDC process, if you will, which allows you to track how many records are new, changed, unchanged, old, and we also have this special latest timestamp update kind of category. So we can look at the data now. And one of the columns that we add here to the original data set, so I'm going to add it here. So it's called record status code. This, you can see like all the gray columns is something that we add in the DataForge in the product to help you track specific things. They all start with S underscore to indicate it's a system column. Record status code is the column I was talking about, and you can see everything is marked as new, right? Which makes sense because we just pulled this data. So this table now exists in Databricks, and we can I can show you real quick where it sits. So if we go here to Databricks, this is the table we created. This is the name of the table. We also have the view name on top of that, which aligns with the name of the source, which is orders, to make it easier. But these are the columns. This is the data. Okay, and second, a table with identical structure. So this one is called Hub 3140. There is also Hub History 3140 right here, which again includes all the same columns, but it's slowly changing dimension type 2 versus the other one was type 1. So in DataForge we decided to give you both. So because sometimes you want to use one, sometimes you want to use another. So we give you both tables, and then you decide which one you want to use. Okay, and again, this contains the same data, as you can see. Okay. So the next, I'm going to return to my SSMS, and I'm going to simulate the change in this data. So I wrote this store proc, which basically adds and updates random number of rows. So note these two numbers. So we added 2 rows and we updated 8 rows. So going back to the DataForge and on the going back to Inputs tab, and I'm going to click Pull Now. So the Pull Now allows you to pull the next batch here. Like normally you would do it on a schedule, but in this case you can also do this manually. So click the button. So we immediately pull the second batch, and while we're waiting for this to process, it kind of shows you, like I'm going to click into the processing tab, it shows you all the details, what's going on. So with timestamps, you can see how long each process took. You can jump into the Databricks here if you want and just see all the details of the job, because behind the scenes, all we're doing is just running Databricks jobs. So you can see all the details about the cluster, about logging, etc., etc. So all right, so we're done now. So going back to the Inputs tab, so you can see like amount of rows is increased now. And if you recall, we added 2 rows and updated 8, right? So you can see it here. So that it shows 2 more rows. And if we click here, new added to 8 changed. So it kind of matches. So, and in the data viewer again, so you can see that this record status code is now C for changed, and U stands for unchanged. So it's basically the same rows. Okay, and if I order on this modified date here, you can see that I'll just sort descending. You can see that all those rows which were changed are sitting at the top. Okay. So that's kind of shows you how easy it is to configure and pull the data, and all the tediousness is automated for you fully in the DataForge Cloud project. All right, so going back to the Databricks, this is our table, which is a target table / gold. We also call it a hub table. So you can see all the columns, updated columns here. So these are all the statuses. Yeah, and you can also query the history, which again, hub is SCD Type 1, hub history is SCD Type 2. So you get both. So this is SCD Type 2. So you can see like all the updated columns, record statuses, etc. I also want to show you how DataForge Cloud product structures data lake files for you, and including all the layers from the raw all the way to the gold. So I'm going to jump into AWS S3. So in this case, this environment is running in AWS. And by the way, we support all 3 clouds, AWS, Azure, and Google Cloud. So this is the data lake bucket, which we configured in AWS, and this is where we store all the data for each of the sources. So in this case, this is our top level folder for the source. These are all the subfolders, so you can see 4. So they correspond to the layers of the medallion architecture. So parsed is the raw data we receive. CDC is what we call the bronze, with like CDC status changes applied. ENR stands for enriched, and it's kind of maps to the silver. We applied some rules and transformations in this layer, and in the example that we saw, it's basically, since we didn't apply anything, it's just a straight copy. And finally, the hub table is our gold, and that contains data for the tables which represent the gold layer, for the containing data with slowly changing dimension types 1 and 2. So inside each layer, so in parsed, you can see there are 2 files which we pulled. So as you recall, we had 2 batches of data, right? So 3071, 3072, and in a data lake we have those here. The 71 is like for Parquet file, and then same in there. And then in CDC, pretty much the same, right? So you have Parquet files, but now we have extra system columns with tracking for that CDC status code that I was showing you earlier. And finally, in the hub layer, we have subfolders for the current and history gold layer tables. So for the current, we have this, and it's stored right here. I also note that Parquet files have already been optimized. The last thing I wanted to show you in the DataForge Cloud is ability to export all the configuration settings which we did into the set of YAML files, similar to Databricks Asset Bundles. So this feature will allow you to manage those configurations in a source control and share them with other developers and make changes and track them. And let me show you how this works. So we go to project that I created, and I click export, and that generates this zip file. So if I open this zip file, there are some top-level configurations for the project, and then there is a sources folder, and there is this orders YAML which I just configured. And if we open this one, so as you can see, it's make it a little bit bigger. So it's really simple. It's just the name description. This is my source query, and these are my key columns. And this again, since we can exclude specific columns from CDC. And any other configurations that you have will go here. So instead of doing this in the UI, as I was showing you, you could just type up the YAML file and go to the project and click import. So, all right. To summarize, first of all, I want to give kudos to the data engineering team for building and deploying and describing the DLT library. It will definitely improve life for many data engineers who had to work with this manually and building those transformations by hand. So that being said, CDC pattern we reviewed would still likely require at least a few hours to fully build and test using Delta Live tables, and probably even longer if you need to ingest data from internal location, connect to, or integrate with a third-party data ingestion tool like Fivetran, etc. And specifically the snapshot process is fairly tedious. And in DataForge Cloud, you've seen me doing this in less than a minute. So really, we automated all of these things, all of this tediousness, if you will, and simplify this as much as possible. What we covered obviously isn't very complex transformation, but it can really be tedious, especially if you need to ingest data and configure it for hundreds of tables, which is not uncommon on the projects where our clients use DataForge. Lastly, this example covers just a small part of the functionality. There is a lot more. We have rules, which I haven't touched on. We have relations, templates, outputs. We support complex types. We support streaming, and so many more. So check out our website. We have a lot of pre-recorded demos, trainings, documentation. We also offer 30-day free trial. So I'll include all the links in this description. Hopefully this was helpful. Look forward to hearing your questions and feedback. Thank you. Bye-bye.